In this question it is given that two solid spherical planet of equal radii are having masses 4m and 9m. Their centers are separated by a distance of 6r. So we are considering that over here we are having two planets having different masses and radius. So the of equal radius having different masses. So one is of mass, take it as 4m, and the another one is of mass, take it as 9m, and their centers are separated by, so the distance between their center is given as nothing but 6r. A projectile of mass m is sent from a planet of mass 4m towards a heavier planet, that means towards 9m. What distance r of the point from the lighter planet where the gravitational force on the projectile is 0? So we are going to find out a point where the value of net gravitational force is equal to 0, or we can say that it is a point where the value of net gravitational field is equal to 0. So gravitational field produced by 4m will be along this direction, let's say g1, and gravitational field produced by this 9m will be along this direction, take it as g2. So at this point, when the net gravitational force is 0, net gravitational field should be equal to 0, or it is a point known as nothing but a null point. So we can write the condition is that the g1 should be equal to g2, and we know the equation for g, that is g into m. M over here is 4m divided by distance. Let's say we are taking a distance is equal to r. So the distance from here to here can be written as nothing but 6r minus r. So we can write as g into 4m divided by distance is nothing but r square should be equal to nothing but g into m. We can take it as 9m divided by distance, we can take it as 6r minus r the whole square. So we can cancel this m and this m, this g and this g, and if you are taking these root on both the side, so the root of 4 we can take it as 2, root of r square we can take it as r, root of 9 we can take it as 3, and root of this can be written as 6r minus r. So we can just cross multiply this one. So this is going to be 12r minus 2r will be equal to nothing but 3r, or you can write this 12r is equal to nothing but 5r, or you can write r is equal to 12r divided by 5, which is equal to 2.4 r. If you know the equation of this null point, we can directly find out the answer. So we can use that equation, x is equal to r divided by under root of m2 divided by m1 plus 1. So if you are having any doubt from where we are getting this relation, so I uploaded a video related to this null point in gravitation chapter. From there you can watch it. So here the x is a distance from mass m1 where the value of null point where we are getting the null point. So we can just take it as the value of x is equal to, over here the r, small letter r represents the distance between masses. According to this question, this distance between the masses is given as nothing but 6r. So over here we can write this is equal to 6r divided by under root of this m2 divided by m1. So this m2 is basically mass of second object, which we can take it as nothing but 9m according to the question, and m1 is nothing but 4m plus 1. So we can write this is equal to nothing but 6r divided by 9. This m and m get cancelled. The root of 9 we can take it as 3, and root of 4 we can take it as 2 plus 1. So this is going to be, and just remember that this plus is outside that root. So the equation is something like this. Should not get confused with this root sign over here. This root sign is only for m2. m2 divided by m1. This is root of m2 by m1 plus 1. So we can write this is 6r divided by, this is 3 plus 2, that is 5, 5 divided by 2. So which we can take it as 12r divided by 5, or you can write the answer as nothing but 2.4r.